welcome back to another stream. And we're doing some more of the Farmer Was Replaced that I played yesterday. I've been thinking about this game like all day, wanting to continue playing it. So without further ado, let's get right back into it. So the last thing we did was the drone movement, I think. Oh yeah, but we never actually solved it. There was the issue with there was an issue I couldn't diagnose. I also got some music for the game. Well, I got the music from elsewhere, but that I thought would suit the game, because for some reason this game has no music. Only this short sequence in the beginning. Okay, so drone movement 2. We've been farming a lot of pumpkins, though, so before we do anything else, I think should have another look at the tech tree. What can we spend all those pumpkins on? The cactus, maybe. But it's probably not a good idea to work on another plant type without getting the movement down correctly. Plant. Use lists to store lots of values. So, I mean, this might be useful later. I don't know what you would use random for. Well, utilities. Unlocks the min, max, ABS, absolute maybe, and random. I'd say that the watering and fertilizer is definitely useful, but for later. We could expand the farm. That should have no... Like, that shouldn't change anything, since we're doing the movement to be able to work on any size. So... Ooh, we also could expand it once more. Let's do... let's wait with any more purchases for later. I think the movement is the most important part to get working right now. So if we try switching it out to the second movement, then we can see it's not working as it should. For some reason. So we call this farming movement function each game tick or whatever, or game loop here, and we have the northbound global variable that we set to true, and then we have the local variable moved, and then we check if the position of the drone on the y-axis equals 0. So if it's down here. Then we want to go up, so northbound equals true. And we check again if we're not on the start position. Then we move east and set the local variable moved to true. So that would in theory work when we're on this square and this square and this square and this square and this square. This one and this one. In theory. And if we're not on the Y0 position, but instead we're on the wait a moment. Should this perhaps be this one? Because this is... Wait, no, this is Y position 0 and it starts at... No, 7 and it starts at 0. So it should be 1, 2, 3, 4, 5, 6, 7, 8. Now this has to be 8. So it has to be minus 1. So it's on 7. Then we set northbound to false. And we move east. And mood is set to true. Oh, so we're skipping... We need to have those as a global variable, I think. So I've moved east equals false, not 4, false. And here we set global moved east. So we're grabbing this variable here and here we need to set it to moved east equals true. Same here, moved east equals true. And now we'll check if moved east equals false. And then we set moved east equals false. Wait. No, wait a second. We need to set moved east to false here as well. So each loop. So we have this gets triggered. We grab the global variables northbound and moved east, and we set moved east to false in case it's been changed from the previous loop, or previous call of this function. And then we check if it's on the first square. If it is, then northbound is set to true, and as long as it's not on this one here, but still on the bottom row, Then we move east, set move east to equals true. Otherwise, if we're on the top row, then northbound set to false and move east. We move east and then moved east is set to true as well. So then when we get to here, then it won't trigger anything here because we moved east. And this won't work either. Will it? No, it won't. Because in the next iteration we'll call this function and move this will be set to false, and once again we will repeat all of this and move a step to the right instead. How do you solve this? This has to be a problem of pure logic that I'm simply not getting. I mean, we somehow need to remember that we've moved east. And then on the next loop, don't move east again, but simply move downwards. Ooh. Could that be the solution? So instead of resetting move east to false, we do a we need to do a check. Here, if moved east, so if we moved east the last time, wait, if not moved east, then we move east, else moved east is set to false. And the same goes for here. Oh. So if not moved east, else moved east is set to false. So we only move east as long as we didn't move east on the last turn. And then if we didn't move east, or if we moved east the last time, then we'd go either north or south, depending on the heading we have. This might work. It should work, hopefully. So we go up, and we go down, and we go... Nice, 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 nice. It's actually working. So the solution was really simple. Simply... Ooh, wait a moment. Okay, so we have an error of some sort. Why is this going on? So after we get back to the start, we go like this. And then we go east and we come back around to this one here. And then we should start going up again. So when we move to this square and we run it one more time, we check if the position is 0, which it is. So move this is true at that point. And the northbound should be true as well. And so we check if we're on this square here, or on this row, should I say. And we set northbound to true again, which is redundant, but no matter. And then we check if, so as long as we're not on the first square, on the first column, then we do something. But if we're not on the first column, we do nothing. Oh, okay. Okay. So we do nothing, which is an issue. Because we never set move east to false. And if we don't set move east to false, then this can't run, so we can't go north. Now it should work. And it works. Nice. Nice. And now it should count everyone and harvest it and begin from the beginning. I think this is actually running perfectly now. So, but just to check, we also need to check the, what's it called? The normal farming, the carrot farming as well. So once this has, hopefully, no, come on. And nice, and then we wait for it to, and like that. I don't know why I did all that waiting. It's not like we're that poor. But if we switch back to carrot season and we run it, there's still the issue with I feel like I want there to be some sort of order on all of this. I suppose we could use lists and iterate through the lists somehow and create neat rows that will go on like forever, whatever. I suppose, but wait, we're... Yeah, we have to be losing a lot of hay and a lot of wood due to all of those carrots. So if we were to expand one more time, the movement should still work perfectly. Should be no issues on that front. And it does. Nice. But now we had issue with all of those carrots. Lists. Use lists to store lots of values. Okay, let's buy that one. And we can read this one. Lists are an easy way to store multiple values in a single variable. You can create a new list like this. The volume is a bit loud. You get new list like this. List and with the brackets. True. True? Why true? Oh, these are the values, so we can have a 2, like an integer or whatever. True and items.hey. The list now contains the values 2, true and items.hey. A list can also be empty. Okay, empty list. You can access an element of a list by its index. The index is 0 for the first element, 1 for the second element, 2 for the third, etc, etc. Plants, carrots. List entities trees, entities carrots, entities pumpkin. Plants list 1. You can iterate over a list using a for loop. The following example sums the all elements in. The following example sums the all elements in the list. The all. Is that a typo or am I not reading it correctly? List 4728. Sum equals 0. For number in list, sum plus equals number. Sum is now 18. The following list methods allow you to add and remove elements. Okay, so list.append adds an element to the end of the list. List equals to 612. List.append 7 to add an item to the list. List.remove removes the first occurrence of an element from a list. Okay. So we don't remove the actual index, we remove the value stored at the first index that we find it. List is now 142. List.insert. So here we can specify an index and the element or value, whatever. Insert an element at the given index. List equals entities.tree items.hey. List insert 1 item wood. Now we have item wood. List.pop index removes the element at the specified index. Okay, if no index is specified, the last item is removed. List pop, okay, or pop1, okay. The len function returns the length of the list. List equals 321. X length list x is now 3. Lists have reference semantics. This means that assigning a list to a variable assigns the same list object to that variable, rather than making a copy of the list. If two variables reference the same list, changes to the list will be seen by both. Ooh, okay. Interesting. I feel like we're getting pretty low on hay. So before doing anything else, let's create another function, and let's call this one grass season, and we have a function called grass farming. So I suppose we can simply do if can harvest. I think that's everything we need to do. And then we can have a grass season dot grass farming. Now it should simply be, oh no, wait. We need to import it as well. That's correct. Import grass season. And now we can run it. This one is also not correct any longer. We need to increase the tick count. That should be perfect. Now we actually start farming from this one when the grass is grown. And now we're getting hay like crazy. Just gonna drink some tea. I went and bought some new tea at the store today, or at the tea shop, or whatever you call it. I went for the very, very basic Earl Grey Deluxe. But you can't go wrong with some Earl Grey. Even though it's basic as fuck. Okay. So while the grass is being farmed, let's do... I think the carrot seasons needs an update. Or wait, we should also do a tree farming season and a bush farming season. I feel like I want to have... wait, no, a forest season. Let's call it that. Having too many trees isn't good. Something like that. I think it said something about that. It said... Let's see... Trees. Trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. The growing time is doubled for each tree that is on a tile directly to the north, east, west or south of it. So we'd want to have a tree, then a, like tree, bush. Oh no, yeah, and then we'd want to have bush tree. So they're like this zigzag pattern of trees and bushes, I think. And we don't need to till the soil or anything to plant the trees or the bushes. I suppose the easiest way to do this would be to check the position of the drone. So if we're on the first tile here, then we'd plant a tree. And then if y equal... Oh, wait. we should be able to do it with some easy math. Like, if we can divide x by 2, then we plant a tree. Or if like the not x, but if the y position is uneven, then we plant a bush. And then we can simply add the x position on top of that, so that should invert it on this line, and then it would go back to being the trees on the bottom row. I think that might work, maybe. Grab this one. So define forest farming. I don't know. Forest farming. And like that. So how do we check if a number is uneven or not? Suppose we could do y pos equals get pos y, and x pos equals get pos x, and we should have it unlocked. Operators is probably the correct one. So we have arithmetic operators. Or wait, is it now we need a list? It's probably now we need the list. So if we have a list called forest plants, maybe, and we set that to entities dot tree and entities dot bush. So now forest plants 0 is the tree and entities bush is 1. I'm just having this, I don't know. There's something telling me that there is a simple way to check if a number is even or uneven. But for some reason I can't imagine how or why that works. I think it's with something to do with the percentage sign. I'm going to look it up to make sure. there's actually a way to do this. How to check if a number is even or uneven in Python, let's say. We can use a modulo operator, the percentage sign, to check if the number is even or odd. For even numbers, the remainder when divided by 2 is 0. And for odd numbers, the remainder is 1. So you call this modulo or something like that, the operator. So we need to check if ypos. Let's call let's set the, what should we call this variable? Plant index equals ypos plus xpos. So if plant index and then what did you call that one again? The modulo operator. If this is equal to 0, so there's nothing remaining after we divide it by 0 by 2, then that means it's an even number. And then we'd want to, or wait, we don't actually need to do this. We'd only need to do plant, no wait. Plant, forest, plants, with the index of plant index. Or wait, no. It's probably better to do the calculations up here, like that, and then we can simply plant the plant index. I think. Because then it should default to trees and bushes depending on where we are. It won't harvest anything like this, but it should still plant stuff. Let's import forest season. Oh. Import forest season. And forest season dot farm forest farming. And play this one. And it's planting trees and bushes. It's actually working. It's actually working as it should. But now it can't harvest anything. So that's the next thing to check. So or wait, we simply have to check if can harvest. That should be everything, right? Because now we're checking if we can harvest, otherwise we do nothing. And maybe we should also plant. So we check if we can harvest, and then we do harvest, and then we plant according to our position. That should literally be everything, I think. Try. Oh, not this one. We want to play the actually the main, and it's farming, and it's planting. And it's harvesting everything and replanting the correct entities as well. So now we literally have a working forest farm. That should be... This has to be the fastest way to actually get the wood resource. Because we plant as many trees as possible. Or maybe not. Because even though the reason for why I did it like this is simply for the trees to be able to grow up faster, since each tree that's close by doubles the time for it to grow. But it feels like it would still have enough time to grow all the way from nothing all the way up to fully grown. So this might actually not be the most efficient way to do it. I'm gonna try to simply... I'm gonna comment out this line here. And then let's plant the entities, not tree. So now we're only planting trees on all positions. And we're definitely slowing down on the growth. But my question was if we'd still be able to reach maturity when the drone comes to this part. No, okay. So the way we did it was actually a lot more efficient, but it's not the most efficient way. I imagine having like some trees grow together would make it pretty efficient. Still, there is a random function, whatever you call it. Maybe if you had like some randomization put into it, so you'd plant a tree regardless sometimes. Maybe. Or did we unlock that one? No. Utilities, random, min, max, absolute, I think, and random. Let's unlock that one. Ooh, we need more pumpkins ASAP, but now we have a lot of wood and stuff. Let's switch back to pumpkin while I'm thinking about the other stuff. So pumpkin farming. Okay, we didn't get an explanation on this one, did we? Let's see here. Tuples. This isn't related to the thing I just bought, but I don't think I actually read through this. Tuples are a great way to combine multiple values into a single value. To create a tuple, just separate the values with commas. You can also unpack them into several variables again. In the code below, the tuple 1, 2 is unpacked into two variables, A and B. Okay, tuples can be indexed like lists, but they are immutable and cannot be changed after creation. Print tuple 1, print 2, print tuple 0 equals 3. Throws an error. Oh, because we're trying to set the first position to 3. But we can't do that since it's immutable. They can also be useful for returning multiple values in a function. Okay. Pretty basic stuff. Still worth it to read through it. Random, here we have it. Sum is a random number between 0 inclusive and 1 exclusive. So returns the random number. I suppose the easiest way to create some randomization than to see would be to simply get a random number. So let's call it rand equals random. Or wait. Or no, rand equals random. No. I'd want to set rand to either 0 or 1. Can we have like 0 if random is greater than 0.5? Else 1? Is this a... No, there shouldn't be any code here. So... You can't do it like that. You can't do it... Can you do it like that? No. Suppose we could do rand equals 0 if random is greater than 0.5. Then rand equals 1. That's one way to do it, I suppose. And then we also add rand. So there's a 50% chance to switch up the positions of if we're gonna plant a tree or a bush. But 50% chance is a lot. That's basically pure chaos. So let's see how that looks in action. Now we get tree, 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 bush, tree, bush, tree, tree, bush, tree, tree, bush, tree, 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 bush, bush, oh. And a lot of bushes, and yeah, this isn't great, I don't think, because now there's a pretty large chance for drone to skip over sections like that. And that screams of inefficiency, I think. Could be better to have a lower chance of randomization. So if random is, let's say, greater than 0.9, so if now it's a 10% chance for it to switch up the position and create a tree or a bush where there should be no tree or bush. But it might be better to simply check, like randomize if we're gonna plant or if we're about to replace a bush with a tree instead. Because there's practically no reason to replace a tree with a bush like here. This decreases the efficiency. We'd want to put a tree there no matter what. Here we have a tree. But it's growing really slowly though. Is this even gonna... No, it won't actually grow up in time. Maybe there is no reason to create some randomization. That might actually only increase the inefficiency. But I mean, it's kind of neat when there are some variants. It's not the most efficient forest farming. Let's do... Wait, we need more pumpkins. So let's go back to pumpkin farming. While I copy and paste this one. So we can have forest farming. Let's call this one. I don't know. Random. No, it sounds weird. Forest. Natural. I don't know. Now we can switch to the natural or the more efficient version if we feel like it. So we could do farming natural if we don't want the most efficient one. For some reason, I don't know. Let's see. What's the next part? We've done a grass season. And we have the carrot season. Ooh, we need to fix the carrot season. This is not a good farming sequence. Pumpkin season is working as it should. Maybe not the most efficient in the way it has to like check everything, but because there should be a way to like check or wait. Is there a reason why you couldn't simply store all the positions of the things you planted in a list or something, and then move the drone to those positions over and over again until you planted everything. So the drone, it will almost look like the drone knew exactly where to go, or had eyes like eyes on the scene, and would be able to tell which pumpkins were dead, and then it would go to them and replant them and continue in like a... The question is how to move the drone to those positions. You'd have to do some kind of math to get the drone's current position and then calculate how many steps to move the drone. I'm gonna think about this while taking a short break for a few minutes. I'm gonna grab some more tea and visit the bathroom. So I'll be back soon. And we might actually try and tackle that kind of efficient pumpkin farming. Yeah, let me think about it for a few minutes. And we're back. So, I made myself a new can of tea, whatever we call it. Not a can, not a jar either. What do you call them? Those pitchers, maybe. A pitch of tea, maybe that's the correct way to say it. So now I just need to wait for it to cool down a bit before I can have another cup. Let's see. I suppose then we'd need to remake the drone movement completely. Like the first sequence would be this one. And then after we did that once, then we'd need to go back. No, wait. We need to do that twice. So the first time we need to go through all of them and plant them. And then we'd need to go through them all again and check the dead pumpkins. And then we need to store all the position of the dead pumpkins while replanting them. And then we'd need to, instead of going through all of them again, then we'd only go to the dead pumpkins in order and check if they were successfully grown this time, and if they were, then simply go on to the next one. And if the next one wasn't successfully grown, then we'd need to replant them and save them to the list again, I think. And by doing that, then we'd move to like all the dead pumpkins and replant them instead of going through all of this. And then we'd only need to do that until we have no more dead pumpkins left. And then trigger the harvest functionality to get the mega pumpkin. Because at that point the mega pumpkin should already be formed. Since if there are no dead pumpkins and no empty spots, then there should be a mega pumpkin. Simply by process of elimination. So, thinking that through, it should make sense. I have no idea how to make the actual movement though. Like, the movement between the dead pumpkins. I think the first thing we need to do is create a new function. Let's call it drone movement pumpkin. And I can't do it that far. Drone move pumpkin, maybe. Yeah. So we should use this one. But I don't need to actually copy and paste it. I can simply import. Drone movement 2. But let's pause it there. There's no reason to keep the drone movement 1. Let's rename it to drone movement old. And we can move this one like way out. Since we won't be needing that one again. And we can likewise remove that from the import. And then we can, instead of calling it drone movement, let's call it drone sweep, maybe. since we're sweeping all of them. And then we need to rename it here as well. Drone sweep. Let's try drone sweep here as well. Drone sweep. And let's call the function simply movement. Since we're actually not doing any farming, we're only doing movement. So if we play it now, it should work as it did before. Neat. Then we can import it here, drone sweep. And we can define a new function. Let's call this one, I don't know. Pumpkin movement, maybe. Drone move pumpkin is kind of ugly though. Let's call it no, let's keep it like that for now. So the first thing to do in the pumpkin movement function, wait a second. Isn't the music coming through? It should be, but maybe it isn't. Now it's coming through. I wonder why that was. Might have been because I minimized the player. That isn't great, but well, at least I caught it now. Over an hour into the stream, but better late than never, I suppose. And I'm not muted or anything? No, I'm not muted. Okay. You never know. When one thing goes wrong, then maybe everything went wrong suddenly. Okay. So what was I doing? Right, the drone sweep. So drone sweep dot movement. Because we can't call it movement like but what if I were to do, instead of doing that one, I'll do drone move. Oh, and I also need to import it. Import drone move pumpkin. Drone move pumpkin dot pumpkin movement. If we were to call that one. Yeah, movement has never been defined. It does appear to be defined in the drone sweep, which seems imported, but you aren't using it. You need to access it through the module name like this. Okay, I just wanted to double check that you actually need to do that, because in that case I could simply call it movement like this and have this drone sweep dot movement and be sure that we aren't calling back to this one. But maybe I should rename. No, let's keep it like that for now. So I drone move pumpkin, but we could simply do it like this. That would make more sense, because then we drone sweep.movement and drone move pumpkin.movement. Keeps it a bit more consistent. So we start by doing a sweep. Wait, no, this might not actually be the best way to do it. Because we need to know when we restart. I suppose we could like return a value here to make sure we know that we actually restarted. But it would be easy to simply copy and paste like this part here. It would be so easy. Let's begin by doing that, I think. There's no need to overcomplicate, so let's copy this whole part of the script. So and let's have another variable called, let's call it move steps, maybe. Let's set that to 0. We need to count how many steps we've taken in total to be sure that we do one sweep and then we do another sweep and then we start going directly to whatever parts have dead pumpkins. So I suppose move steps plus equals 1 should do this on each part that has a move function call. So equal as well here and here and here. Now we should increment move steps by 1. Also should set it to be the global variable as well. And should check if move steps is greater than or equal to. Let's create another variable called farming tiles, and let's set that to get world size times get world size. That should get us the number of farming tiles. So if we moved over the board two times, then we do whatever is in here. Otherwise we'd be out here doing all of this. So this code will only trigger if we're on the how do you call it? On the third pass, at the beginning of the third pass. Then we need to move towards a specific coordinate instead of moving like this. But we also need to know where that coordinate is. And we have no way of knowing that as things stand now. Let's move this one down here. So we can also check the pumpkin farming. Because we need to know if we farm the pumpkin or not. Let's simply say return here. And we can check if this is working as it should. Because we have the pumpkin farming and we have the drone move pumpkin movement. So now we should do 2 passes. Okay. Oh, we need to call those as functions, not as a variable. And now it should work. So we do 2 passes. But we also need to modify this script here to somehow store a global list of all the positions of the dead pumpkins. And it should stop now, and it stops. Great. It does harvest though, since well, it's working as intended, I suppose. But we could do everything in one script, both the drone movement and the farming. But I want to try to split them up into 2 separate scripts, or whatever you call these text windows. So let's stop this one and create a new one called, let's call it Pumpkin Season 2. Let's call this one old and then switch back to Pumpkin Season. So we have the old one as a reference. So maybe we can simply call it farming. Now the question is, what kind of variables do we need? We need some sort of list for the other positions. So I suppose can we create a variable called dead pumpkin, and we set that to a list and like an empty list, and then we have dead pumpkins, which is another list, and then we should be able to add a dead pumpkin. Wait, well, let's say simply a list here. Should be able to add a list of, let's say these are the coordinates. Then this should be a list of lists. Also need to make sure this is a global dead pumpkins. If I was to call this, let's call, and let's print dead pumpkins, and no movement. Then the list becomes longer and longer and longer. Interesting. Okay. So, what do we do now? We need to check first yeah, first we need to check if we can, if ground type is grassland, because then we need to till it to be able to place a pumpkin. And then we do need to check if we can harvest it. So if we can harvest equals false. So if we can't harvest anything, then we plant a pumpkin. Because this might mean that we're either on a unplanted part of land, or it might mean we're on above a dead pumpkin, or it might be with above a simply a empty tilled land. I don't know if there's a way to check if the pumpkin is simply dead. That's the information we need. Planting a new plant in its place automatically removes the dead pumpkin, so there's no need to harvest it. Can harvest always returns false on dead pumpkins. Census. Get entity type. Returns the type of entity or ground that is under the drone. But would it return a dead? Wait, I could maybe check if there's an entity below. So as long as we can harvest, as long as we can't harvest, but there is an entity below. Wait, no, that will work on growing pumpkins, and we don't want that. Let's try. Let's start by planting. If can harvest equals false, plant. Okay, this should simply plant one pumpkin. It shouldn't do anything else. Pumpkin season farming. So if we start this one, yes, one pumpkin, and nothing else happens. And so now we can print get entity. Let's do get entity type. Let's see what it says. Start this one. Entity is pumpkin. I want to see how it looks if it's dead. It's still set into this pumpkin, I think. Wait. Let's do a simple planted equals false. Global planted. And then do planted equals true. And not like that. And planted equals false. Now it shouldn't kill any dead pumpkins. I still need to get the dead pumpkin though. Which turns out to be harder than I expected. It felt like there was a much higher chance of there being a dead pumpkin than this. Come on, one dead pumpkin. One. Come on. Yes. Oh, it says the pumpkin. Nice. Okay, then this will be possible. So it's dead underscore pumpkin. Wait, don't tell me there was a mention of that on the pumpkins. No. Okay. So now that we know that, we can remove this and this and this. Okay. So we'll always want to do this check here until the soil, if it's grassland. And as long as we can... Wait. We never want to harvest. I feel like we need to... Wait, if can harvest equals false. This would trigger on a dead pumpkin, since we can't harvest a dead pumpkin. So we need to do a check if get entity type equals entities dot dead pumpkin. Then we'd need to store its location. So dead pumpkins dot append, and then we'd need to append get pos x and get pos y. So we'd append our drone position if we found a dead pumpkin. But I feel we'd also need to somehow remove need a way to remove the dead pumpkins from the list somewhere. Because right now we'd go through everything once, plant all the pumpkins, and then we'd have some dead ones, most likely. And then we'd go through everything again, and on every dead pumpkin we'd add our position to this list here. And we'd also replace them. And then next time we'd want to go to that position directly. And we'd want to remove no, we should always remove it, I think. We should always remove it from the list. So we only... Oh, that's actually a better idea. So instead of only checking if it's a dead pumpkin, we should also... Or wait. I thought I had a best idea for a second, but it slipped my mind. Okay, one more time. We go through it once, then twice. We add all the dead pumpkins to the list. Then we need to go to the first dead pumpkin in the list. Let's say it's here. And once we're there, then we need to plant another pumpkin. But we'd also want to save this position for next time, because we're still not sure if it's gonna return if it's gonna be another dead pumpkin when it grows up. So we need to check it at least once more. So if we plant something, then we don't want to remove it from the list. Or we want to re-add it, should I say. It's probably a good idea to always remove it from the list. I feel like there's so many ways to do this, and I don't know which is the best one. I could like expand on it and have several variables that keep track of how many times we've gone through like the whole farm. Stuff like that, but I don't want to do that. I want to keep it running indefinitely. Okay, let's go through this step by step. So we check if it's grassland. If it is, then we till. This will only be the first time. Then we'll always skip this one, and then we'll check if it's a dead pumpkin. If it is a dead pumpkin, then we append it to the list. And if it's either a dead pumpkin or if it's simply tilled soil, we will plant a pumpkin. So in other words, the only thing that won't happen here is nothing will happen if there's a grown or growing pumpkin on the tile. But we also need a way to move towards the position of the dead pumpkins. That would be here. But I don't know if it's a good idea to keep these two separate. It's probably a good idea, but it feels more complex somehow. Might be better to keep them together. Let's say if I were to no, let's copy this one to pumpkin season like that, and let's put those global variables here, and then move this out of the way, and then we can expand on this one. So and then instead of calling call this fine program maybe, or process, let's call it process, and the process is movement, then farming. This is the process. So we start by the... oh wait, this should be at the bottom. Has to be on the bottom. Ooh, like that. And then we'd also want maybe to put them in order here. So we actually do I don't like this script getting this big though, but no, I don't like this. I really don't like this. I want to keep the movement and the farming separate somehow. Maybe... what if instead of doing it like this, then we let's see, we import drone move pumpkin. So we import everything from this script instead. That should be cleaner and should allow us to do pumpkin season process, if you call this one. Then we will do both the movement and the farming, but we'll do drone move pumpkin, that movement. So now there's only one thing to change in here. And let's say if we wanted to do it the same thing here, then we'll also do a define process, and let's do drone, and we need to import it as well. To import drone sweep, and then we do drone sweep dot movement and forest farming natural. Was that the function name? And then we could simply process like that, and then we could do then we could remove drone sweep from here, and likewise remove these. Oops. And let's see, we could do forest season.process instead. Now this should run the whole forest. Nice. Let's clean up the other scripts as well. So we have grass season, define process, and we do also need to import drone sweep, and we do drone sweep dot movement and grass farming. And now we'll likewise be able to do the process for this one, and it's only grass, infinite grass, and one carrot season. Oh, it's this horrific thing. Define process, and we do the import as well. Import drone sweep, and we do drone sweep not movement, and the carrot farming. Now the carrot farming should technically work as long as we do the process. No, drone sweep. Did I spell it correctly? Yeah, I did. And it does, technically. But we're skipping that one. Need to add a tiny delay. Wait, do we need... Oh no, it's because we're calling the movement before the farming. That's not ideal, since we're starting on a square. We should always always do the farming before the movement. I didn't think of that. So we want that one, and on that one as well, and here. Oops. And likewise in the pumpkin season here. I also want to rename these to farming. There's no need to overcomplicate matters, and you can keep them similar. Farming, drone movement old. Forest. Let's do farming natural. And farming. And now we can always call the process like this. Oh no. Get into type on the function get into this is this is a function, that's correct. So this will only farm, it will only replace all of. Let's see if it works and appends the dead pumpkins. It should do it up here. And there seems to be something going on. But now it's stuck because we've done it 2 times. Yeah, that's correct. So we need some way to pass along coordinates to the drone. So let's simply also check so the grass season process works as it should. Didn't break anything. No, seems to be working. And the forest season. Oops. The forest season. And it's calling the natural cycle. Okay. I don't think I strictly need this anymore, but let's move it up here. Yeah, I forgot about the docking function. But it's kind of useful, I suppose. We can dock these old ones together. And we can also dock this one to the daybreak one, since these are technically, or I suppose there's no reason really to dock them together. We could dock a lot of stuff, but there's no point. The drone sweep is pretty crucial. And then we have the pumpkin season and the drone movement for the pumpkin. Like this. Should give a good view. All right. So pumpkin season. We did manage to create the list of coordinates, but now we need a way for the drone to move towards those coordinates. I suppose the best way would be to simply create a function that like this move function, but which moves the drone to a coordinate no matter what. So let's say we have define let's call it I want to call it move as well, but we can't call it move. And call it something else. Move chord, maybe. Move chord or move coordinates. And we want to pass along in the parameters we want to pass along X and Y. Sweet and simple. And then we'd want to while gets was X does not equal X. Then we'd want to and while get pos Y does not equals Y. Or should I say while get pos X then does not equal X. And or is there an and or get pos Y does not equals Y. Is this a valid function call or a valid loop? Well, wait, and or I suppose we want to check if we're not, as long as we're not on the correct X position or we're not on the correct Y position. So then we want to check if, and we also want to do this simply once, so or wait, no. we need to update. So xpos equals getpos x. Ooh, that's right, we also need to set these as functions. And ypos equals getpos y. If xpos now comes the part where we need to check whether we need to move or not. So I suppose we should simply do if xpos is less than x. Oh. Then move east. Else move west. And then we need to check if ypos is less than y. Move north. Else move south. So this should move us in the direction we want to go. And instead of calling all of these movements here, wait, this is a copy of drone sweep, isn't it? It should be, with some extra stuff here. But instead of saying moving east, then we'd say move, no, we shouldn't say move at all, we should say move chord. And we'd want to go x, so get pos x plus 1 and get pos y. Or wait, can we set it to... Let's not confuse it anymore. Get pos y. Also need to have these as function calls, I always forget. Then this should move us one step east. And that should be everything it does. So this should fundamentally work. So we replaced the move function with our own function here. That moves it towards the coordinates. So if I were to start the process, then it should start farming and then go east. Or wait, this is only on the lower one, so it should, if it moves east here, then it works. and it doesn't work. Okay, what is going on? What is going on? This wasn't my intention. We need to check while get position x does not equals x. So while the drone is not, but it should be on the x-axis, or not on the correct y-axis. There's really no reason to use these variables here. Simply, I thought I'd need them more, but I don't think so. And then everything it does is we check if the drone position is further to the left than where it's supposed to be. If it is, we move east. If it I should probably... Oh wait, this is the issue. We need to do else if get whose x is greater than x. Then we move. Because the else statement triggered when we were on this correct position, and then we moved west again. And we shouldn't do that. Same thing here. We should check if we're on the correct y position. Like that. This should work now. So... yeah. And we should sit again. Yep, it triggers. No issues. So we can instead use the move chord function here. So we need to move east here as well, so it's the same one. And here we need to move north, and that's y plus 1. And south is y minus 1. So now we replaced all of the move functions in here with our own custom one. Let's see if it works. And it seems to be working as it should. But we're only moving one step, so there isn't really a large difference. But now if we were to, for example, write 2. So if we want to move 2 steps, now we should be able to move 2 steps. Yeah. But there is some issues. Oh, it's the looping thing. We can't go to the Y13 because as soon as we get to Y12 we loop around. So we're stuck in this infinite loop like that. We should do a check for that in here to make sure that doesn't happen, because that would be very confusing. Let me just refill my cup of tea. Good stuff. Alright. So we need to check that the X position isn't invalid somehow. I suppose the easiest way to do that is to say do a or wait you that depends though. As long as you want it to loop, then the looping is as much a functionality as it is an issue in this case. I'd say most times it's actually a feature. I suppose we could also have a loop. Set that to false by default. So, but if we do... wait, no, true by default. But if loop equals false, then we'd want to check. So if x is greater than get world size, and then we'd want to wait, what's it? If statement. If x is greater than get world size, and this is a function as well, then we want to set x to get world size. Else, if x is smaller than negative get world size, then we'd want to set x to negative get world size. Or wait. Or no. That's wrong. We don't go negative like that, but else if x is less than 0, then we'd want to set x to 0. And then we'd want to do this for y as well. So y like that. So if we set looping to false when we call the function, then we would check this. Wait, else if and let's say now on the move north here, northbound, let's say we pass along false, then we don't want it to loop, so it should move up and get stuck here. It doesn't. Why? Because literally y get world. If y is greater than get world size, so if let's say y is set to, I don't know, 12 or 13, Or wait. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why should be set to 12? When this gets called. This has to be called here. Can we do it by step, or is that too... It's this one again. Comment that out and then we do step by step. Now we're on the farming process. Let's see, so... Wait, can I press... I can press this one as well. Check, check, check. If northbound, then we go by this one and we pass along to +2. And it's set to false, so we don't loop. And it should check if x is less than get world size, which it isn't. Else if it's less than 0, which it isn't. Else if it's greater than world size, which it isn't. And if it's less than 0, which it isn't. And as long as the drone position isn't on the correct spot, then it will move the drone to that position. And then we'll do it all again. And it will do this. Let's see if I can speed it along until we get to the interesting part. Not this one, but the next one. Okay, now we're getting close. So we move to this one. And we're still... Okay, so now we're on the correct one, and now we're gonna farm that plot of land. Farming. And tills it. Checks for dead pumpkin, but nothing, so it plants anything. And now we go to drone movement again. So check a bunch of stuff. And now we get to move chord. Now it should be trying to move us to Y12 because we're on Y10 and we move up by 2. And we pass along false here. So if loop equals false, which it does. If x is greater than world size, which it isn't, x position doesn't matter here. And now if y is greater than get world size, which it is now, then we change y, which we... For some reason we're skipping this part. But we shouldn't skip this part. I mean, y has to be 12 at this point. Should have done a print function. Let's see. What if I were to print? Can I print a string like this? So we print the y plus y, I guess. Can I... Oh, wait, no. Let's simply... Oh, okay, there was an error. Cannot be used on... Wait a moment now, wait a moment. Did you see that? The operator plus cannot be used on the operands plus and 12. So it is literally 12. Oh, wait a moment. I'm stupid, aren't I? I am. Of course it isn't less than 12 when we're 12. We start on oh my god, we start on 0, so of course it's less than... It isn't less than 12, it is 12. Okay, I'm retarded. I'm literally retarded. So we need to check if it's the -1. And if it is, then we set it to get world size -1. Because we don't want to set it to 12, we want to set it to 11. And... right? Yeah. We check if it's greater than 11. If it is, we set it to 11. And if it's less than 0, this should still be correct. But it's these two that need to be changed. And now... Wait. We also need to restart everything. Now we skip, but it doesn't work downwards for some reason. Y should be set to 0. If y is less than, because this is 0, and if y is less than 0, y equals 0. Why isn't that working now? This feels like the same issue but in reverse. Oh, I know why. I know why. Thank God. Thank God I didn't go too deep into this and mess everything up. It's because I had looping on still when moving in the other direction. So while moving down we had looping on. That's why it looped instead of breaking. But now it should skip one. And if it can't skip it, it will... Perfect. Nice. But we don't actually want to move 2 spots. This was simply to test it, and good thing that we did. It showed the potential headaches I could have gotten if I didn't solve this straight away. But now that's been solved, let's just try it. Now it should still be on each one of them. Yes. Great. Now we somehow need to... Wait, this should be pretty easy actually. We need to return. Or wait, no. We need to somehow pass along the dead pumpkins list to the movement or the coordinates from the dead pumpkins. But how? So we start by farming. So we do all of this. And then we move. We do all the movement. This segment here. That calls to this one here, but this segment here in essence. And we do all of that for one full farmland, one full I don't know what to call it, but one full pass. Let's call it that. One full pass of the fields. And then we do it again. This time adding the dead pumpkins to our list and replanting them. And after that's done, we won't be running this code any longer since we have this check here. So after 2 runs we will get stuck because we won't be able to farm anything more because we won't be moving. But I suppose we actually need to know how many move steps we're on. Because let's say we do one pass. We start with one pass where we plant everything. And then we do another pass where we collect information on all the dead pumpkins and replant them. Then we have a list of dead pumpkins. And then we want to pass that list along to the movement script. And then we want the movement script to move according to that list until all of them have been gone through. And then we want to do it one more time. But this time we won't be... We also need to clear our local farming dead pumpkins list after we pass it along. So then on the next pass we check if they're dead or not. I suppose we need a global variable. Let's call it dead coordinates. And let's set that as an empty list. And inside the movement script here, let's reference the global dead coordinates. Like that. And then we should be able to let's say any movement here. We need two arguments or parameters, I think. And the first one is a list. Let's call it coordinates. Oh no, dead pumpkins, which defaults to an empty list. And we'll also need a override, which would default to false. So if override, then dead coordinates is equal to dead pumpkins. So we only override our dead coordinates if we explicitly call it that. Otherwise we'd always override the dead coordinates even if they're full, but by simply not passing anything along. This shouldn't break anything. We should be able to run it. Yeah. Nothing breaks. So that's good. And now we need to know when to send over the dead pumpkins coordinates. We essentially want to do that when move steps is greater than farming towns. Let's say we have the move steps counter will only work when we go over all the tiles. As soon as we only go into the closest dead pumpkins, then we can't check for the move steps. Then we need to check. We need to check if we've moved the length of the dead coordinates list. If we've done that many moves before. So essentially we need another variable here. Let's call it need coordinates. That's false. And then we should be able to check. So after the farming, let's say The question is if we should do this before we pass along, because my thinking is we should like check if drone move pumpkin dot need coordinates. So if it needs coordinates, or wait, no. I'm stupid, I think. We do that down here. Here. So else. If it needs coordinates, we pass along the coordinates, which are the dead pumpkins. And we also say override to true. Otherwise we don't pass along anything. So now it should still work as before, because we never set need coordinates anywhere in here. But let's say let's also check at the end of this if it's move steps is if we done 2 sweeps over all of this, then we set the need global need coordinates, then we set the need coordinates to true. And if we override, then we set need coordinates to false again. This should pass along the coordinates before getting stuck here again. After it does 2 passes. But we do need to check it here, because on the next because here when this is over and move steps is finally above or equal to farming tiles times 2, then we do the farming. And then this will get called again, and this time we want to pass along this. But we're still stuck here now. Now we need to Now we need to actually move to the next coordinate. I suppose we need another global variable for that, called, let's say, current coordinate. Let's set that to 0. And let's do global current coordinate. And need to check if current coordinate or wait, no. If move steps is less than or equal to farming tiles times 2 plus dead coordinates dot wait no len of dead coordinates, I think. Len collection, get the number of elements in a list, set dictionary or tuple. So we check if, as long as we haven't moved through all of the dead pumpkins that all of those coordinates we collected, then we'd want to move again, is my thinking. Else we'd want to set move steps to farming tiles times 2, just to reset like the step counter to what it was after those 2 sweeps. And it isn't the most clear way to do it, but it should work. And we'd also need to set need coordinates to true, because then we need new coordinates. And then we also return, because we don't want to call any of this code down here. And we also set the current coordinates to 0. Current coordinates plus equals 1. We want to do that at the end of every movement. And then move. Wait, wasn't it move chord? Move chord. Move chord. Dead coordinates of current coordinates. We want to pass along those. And it shouldn't matter, the looping or any of that shouldn't matter at all. Because we shouldn't be able to get coordinates that are outside of the board, or whatever you call it. It feels like I'm missing something, but yeah, we need to reset the Dead Pumpkins list as well at some point. We do that afterwards. After we pass along the Dead Pumpkins. Then we set the Dead Pumpkins to an empty list. We should need to reset it afterwards. I don't know, man. We might actually be done. Or maybe the whole game will crash. Let's see. This is kind of exciting. Hopefully it will work as intended, but maybe it won't. I for sure hope it will work as intended, because that would be very nice. Okay. So this is the first planting stage. And it immediately broke. Okay. Why though? I need to take a very short break. I'll be right back. And we're back. So, something has gone wrong. But not something I even imagined could go wrong. I mean, this was only second pass. I need to see this one more time, because we went through this once. And we're completely stuck in this while loop. So while get position X does not equal X. Okay, so X is set to 12. It's because we're expecting it to loop, right? I mean, it's in the last move east here. On the last step, like down here. Move east, then we expect to move X to 12. And we expect it to loop. So it gets here. I suppose there's a fast way to see if that's the issue. Simply by always saying looping, let's say false, and the same for, wait, this is it should only be on that one. Now we should get stuck here. I could see why you'd want the debugging tech tree to simply scale down all of this, because it takes a while. Oh! Well, something happened. Oh, because when we got here, we couldn't go any further. On the next pass, we'd want to go up instead. Which is logical, considering when we get to the bottom, we reset the direction. So we go up, and then we get stuck on this loop, because here we actually have the looping set to true. If we set this to false, then we'd go through all of this, and then we'd get stuck going up and down here instead. Like that. But I don't understand why there's an issue now. Because it did work previously. To move, I think. Or did I simply abort the... No, I didn't abort the drone too quickly beforehand. I don't think. Because X was 12. Might as well play it. We need some kind of check, I think. That... Wait, no. No, this is wrong. We want it to be able to loop. But we need some kind of check. Because when X is 12... Then... Oh, that's right. Now I see what the issue is now. When X is 12, we move east to 12, which resets us to X0. And that's where we get stuck in this loop, going infinitely. I don't know why I didn't make that connection in my mind, but it makes so much sense now. So we get stuck here, going constantly east. So we actually need to do another check. I suppose we should do it at the end. Like if after we already moved. So if X or Y or just if X we can do XY is greater than get world size minus 1. Then we break the while loop. So we break out of it because we've already looped. And L if XY is less than less than 0, we'd likewise want to break. If this works, like if you can type it like that, well, no, not valid expression. Okay. I mean, I could do it like that and that, and then do an or. Y is it. And or Y is less than 0. Or wait a moment. I think we also need to check. Can I do it like that? We also need to check that the drone is close enough to the edge, right? Or when does the move position, like when does the get pos get updated? Guess the current X position of the drone. X position starts at the 0 and but the question is, Because this will technically work to fix the issue, but it will bring in another issue. And that other issue is in case you want to have a custom coordinate. Let's say we're here, and we want to go, let's say we want to go here. Then we will only move once before we check the code, and then we break the loop. Well, we want to move all the way. So that's not great. It won't matter now though. I don't think. So let's, no, can wait. Oh, and these should be there. Let's try it out. This should break the loop and allow us to continue, hopefully. And if I'm not mistaken, this might actually be working. Hopefully. Oh, I'm excited. I'm so excited. Come on. And no. Too bad. Try to read the variable dead pumpkins before the value was assigned to it. Why wasn't any value assigned to it? Wasn't this? This should have assigned all the values. Let's run that again, and I'm gonna check this code here for triggers. Because it should be... It should work. It did 2 passes. So, first pass. And now. And it, yeah, it depends. And now for some reason it says there's nothing added to it though. Let's see here. Let's print dead pumpkins before this happens. This should tell us if it's really empty or not. But I don't think it's empty. It says it's empty, but it shouldn't be empty. It really shouldn't be empty. Getting low on carrots. All this pumpkin farming is costing us a lot. Okay, might want to move this out of the way because it should read it out here. Let's see. No. What? Oh, okay, I'm actually retarded. We also need to assign it at the... We need to make sure it's recognizing this as a global function. Because now we tried to literally invent a variable on the spot. That makes too much sense that I'm almost ashamed. Okay, so now we might actually have a working run, maybe. It's been over 3 hours to simply get this pumpkin farm working, basically. Or maybe 2.5 hours. We did a bunch of other stuff in the beginning, like fixing the formatting on the other farms, but I don't wanna say that it's gonna work this time in case I jinx it. Maybe. No. Okay, we have another here. You try to call something that is not a function. Oh my god. Simple syntax error. But I also remembered something that's kind of embarrassing. There's no harvest function. There's planting and everything, but there's no actual farming getting done. And I don't know how to call that. We needed to make sure that dead pumpkins is 0. Yeah, wait. Isn't it actually really easy? As long like else if. So if we can harvest and dead pumpkins equals none. It equals none. This might harm the first pumpkins though before it reaches a dead pumpkin. So no, it's not this easy. We need to check for something else as well. I suppose we could simply have a first find and call this false. Maybe, and we set first find to true. And as long as this and first find. So as long as we found at least one dead pumpkin at any point, and the dead pumpkins list is completely empty. Then we can harvest. Yeah, this should work. Hopefully. It feels like I've said that 10 times today, but this might just be the one run when it actually works. Come on. So we're adding them to the list. And first finally it gets triggered a lot of times, but that doesn't matter. And let's see. No. Wait, try to read the variable current coordinates before the value was assigned to it. Oh my god, current coordinate. Oh my god. All of those typos. They're kind of making me mad that I didn't catch the typos earlier. Okay, fingers crossed. No. Move chord takes 3 arguments. Oh wait, so I can't simply pass the list along. I need to do dead coordinates. So wait, because this is a list of lists. We have to do it like this, and then like that. Is this the correct way of doing it? Because we want to pass along the first item in the list and then the second item for X and Y. But since there's no pre-compiling, there's no way to know if there's an error in my programming now. It can catch some errors, but not all of them. Okay. Come on. No. Wait. We got an achievement though. Pass an argument as a function as an argument or whatever it's called. But there's an error. Trying to use does not equal on the function getPosX. This is the function object itself, not the function's return value. Did you mean to call the function with the call operator? What? Why is this an error? This shouldn't matter, should it? Trying to use the... Wait, is there something... Oh, I'm appending the functions to the list and not the values they return. That's why it's complaining. Because I was thinking like, what? This is correct, but since x in this case was a function, not a value, but now it's a value. Okay. Do I have another function calls here that's wrong? Can't find them. All right. Let's try this one more time. It feels like it has to work at some point, right? There can only be so many errors before things click into place. Or that might just be my naive hope, but... Alright, come on. No. Try to read the variable current coordinates. Wait. Try to read the variable current coordinates before a value was assigned to it. Oh, current coordinate. Can you search? Current coordinates. Okay, there's no more misspelling of that one. Okay. Try it again. And come on. And we got an error. The index 28 was outside the bounds of the list. Oh, for the current coordinate. Yeah. Can I... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh. Move steps, this is wrong. This should have been as long as it's less than or equal to. This has to be 28 then, so farming tiles, which is 8 times 8, 64, no not 8, 12 times 12. Let's do some math. 12 times 12 times 2, 288, and move steps is set to 288. Plus 28, let's see, plus 28, 316, but if move steps is set to 288, then we must have oh, I see. We never actually update the move step, do we? Because we set the move step in here and not in here. So here we should say move steps plus equals 1. And the same goes for here and here. And then we remove it from these. And one more, there we go. Or wait, I suppose... this doesn't make much sense. This would make more sense. Now move step should pass. Now this should get out of bounds, whatever you call it. Move steps should be... this segment should be triggered at some point. And reset the move steps to 288. And the need for coordinates. And the current coordinates to 0. Which would then reset everything, hopefully. Let's try it out. No. Move. Oh, we need to global move steps. Always forget to do that with the global variables. Yeah. Come on, come on, come on. So it's checking all. No. The index 0 was outside the bounds of a list. What? Oh wait, because we're moving a lot of steps now. And okay, no, okay. I see what's going on. We're moving too many steps. We're moving like crazy like that. But we should technically only count the move steps when we get to them. Suppose we could do... Got two options, either move this back to where it was before. Yeah, let's do that. The other option is more complex and there's really no good reason for it. So here and here. Wait, and here. There we go. Now that should work as before. And now instead we add one to move steps here. So we only increment the move steps by 1 each time we reach a dead pumpkin after we've done all the spiraling stuff. Let's try it again. Okay. This has to be the last one. That's incorrect. It simply has to be. And it might actually be working. No. The index 35 was outside the bounds. Because for some reason this never got triggered. Is my guess. Current coordinate 35. Let's use the calculator. 288 plus where do we have it? 35. $323. Oh wait, we're supposed to simply do it like that, as long as move steps is less than. Is this the solution? It might actually be the solution. Simple as that. To make it non-inclusive. Because it shouldn't mess anything up below that, I don't think. All right. Let's see it happen. So it checks everything. And it goes and checks everything else again. And it might... And almost! So close! So damn close! So we're stuck at... We're stuck in here. Oh wait, are we calling... What are we calling? Oh, is it simply jumping back and forth between these two functions? Because there's nothing for it to do? I mean, dead pumpkins... It can't be simply that first find. It is false. How? Oh my god. Oh my god, another one. This is literally the last piece of the puzzle. It has to be. Set as a global variable, and now it will work. Now the optimized pumpkin farm will finally work. Finally. And even if it doesn't work, then I'm done for today. It's been over 3.5 hours and I'm pretty tired. But yeah, it's been a really fun time. And I think I'll be back with some more of this tomorrow, maybe. Or maybe we'll do some actual programming, I don't know. I haven't decided yet. checking everything. Going back, checking, and it's waiting. And we get a little... Wait. No, this is true. Dead pumpkins. Okay, so it isn't equal to none. But it's equal to empty brackets. That's annoying, not gonna lie, but I feel like, okay, this is the last one. This is the final one. I just couldn't end it on that note. I mean, come on. Wait, did we forget the clear function? I think we might have forgotten the clear function, so after this is done, then it might simply stop. There won't be like a repeat. But getting it to work with the clear function should be an easy solution. One that I might implement next time. Oh, come on. Ooh. Wait. Wait a moment. Okay, something is broken. It's the harvest function. I can see why it doesn't work, but I don't have a solution in mind straight away, so I think we're just gonna call it here for today. It's been fun, and it looks like there's only a tiny part left to do. But as I said, I don't have the time for it today. So yeah. Thank you so much for watching, and I see you in the next stream. Cheers!